Testing 1 2. Testing 1 2. Testing 1 2. My microphone. Here we go. And we're live. Microphone wasn't working. It seems to be working now. I wasn't watching the time. And I got a lot of things going on here. I got my computer in front of me. I got a monitor over here, and I got another computer over here. I was checking email, so let me close that one so it's less distracting. This is RockSim Live. We're here to answer. And we're live. Microphone wasn't. The speaker was out on that one. So, my name is Tim Van Milligan. This is RockSim Live. We're here to talk about the RockSim software, RockSim, RockSim Pro, or the Launch Visualizer, or general questions on designing rockets or building rockets. Carlos says audio is faint. Oh man, I don't know about that. Terry says it's time to build rockets. I guess like a lot of people, as I'm doing these, they're doing other things at the same time, like building rockets or whatever, which is really cool. He says he built a PTP-powered RC glider. Cool. Art Applewhite says, howdy from Texas. Cool. Oh, we got Egghen Balta. We have HPR Rocket Stuff from North Dakota here, and Robert Monday. Awesome. And Robert says, hello Tim, I am building a Wildman 4-inch Vindicator and plan on using redundant RRC3s. How do I or can I sim this in RockSim? Thanks, says Bob Monday. Okay, we got our first question. That is great. Let me switch screens here. And this is the Apogee website. We got a brand new rocket motor that came in this week, an Aerotech J615. And if I just said that, J615 with the Super Thunder propellant, you would probably say, okay. But this one has something really cool about it. If you go to this picture here, and you look at the parts, and you might notice this strange one down here at the bottom in the middle. So what the heck is that? And that's what makes this this particular rocket really interesting, because that is an aerospike nozzle. So that makes this rocket motor the first one for model rocketry that has an aerospike nozzle. Which is really cool. You might be asking, what's an aerospike nozzle? And a traditional nozzle is like down here. It's called a bell nozzle. And you have your combustion chamber here, and then the gas flows through the throat of the nozzle and then comes out through the bell part. And the problem with bell nozzles is that they have to be designed for a specific altitude that you're launching your rocket from. Here's the optimal. You can see the flame is coming out nice and straight, and that's what we want. You want it nice and straight. But if the rocket is, if it's designed for high altitude and you launch it at a low altitude, it's what's called overexpanded, where the pressure inside is too great, and the flame, the flow collapses, and you get the gases coming out in kind of this, I'm thinking circular, but it's not circular. It's curved. Where in the optimal it's straight. And if you take a nozzle that's designed for sea level and you take it into outer space, you get what's called overexpanded flow. And again, you get the flow in a direction that doesn't give you the highest efficiency. And so the aerospike nozzle tries to give you straight flow no matter what altitude you're from. So you're flying from. So they're optimal in all cases, sea level, design altitude, and in outer space, which is really cool, because you don't, on a typical rocket, like on a Falcon 9, the second stage nozzle is a lot bigger than the one that's used on the ground, and that's because to prevent it from being overexpanded, you need a wider nozzle. So aerospike nozzles are good for rockets that are single stage to orbit, SSTO it's called. So that's the cool factor of it. And then here is a picture of the nozzle, and here is the back side of the nozzle. The question is this kind of overkill for model rockets? And the answer is probably yes. It's a really cool nozzle to have, and you can, you know, if you like doing show and tell with your friends when you're on the launch field, and you don't think you have anything to talk about, you could whip this out and say, ah, look at this. Guess what this might be? And that would be cool. So that's what I was looking at today, is our new Aerotech J615 ST. ST stands for Super Thunder, so that's the type of propellant. It's similar to their Blue Thunder, but it's super. I think it burns a little bit faster. And it comes in a 20-second adjustable delay. That's what the A means, is adjustable, and the 20 means that the maximum length is 20 seconds. So you'll find that at ApogeeRockets.com, and you'll find it if you go to our homepage. You know, it will be down here at the bottom under New Products, right here, to the J615. Okay, so this is the Apogee website. This is where you go to find cool stuff. If you're new to rocketry and you're looking for RockSim, you click on our banner bar. It's got little arrows on either side. You'll scroll through it, the carousel, and this is the RockSim Launch Visualizer. It actually takes you to a different website. It'll take you to rocksim.com if you click on it. Here's our newsletter, which we suggest you sign up for. We can help you get a cert, and then here's RockSim 10. So this is where I suggest you click, and that will take you to where you can download a free trial of RockSim. And if you scroll down on our page, you'll see this banner that says free RockSim training, and that's what we're doing right now. If you click on the link, it takes you to our archive page. Today is June 2nd, and we are on episode number 123. So this is the kind of stuff that we talked about last week, you know, like opening up a second instance of RockSim onto your Windows computer, which I didn't know we could do until last week, which was really cool. So let me see what's going on in the comments. Carlos says, you aren't orange today. Yeah, last week I was having problems with my camera. The setup is exactly the same as it was last week, so I have no idea what happened last week. Art Applewhite says, do you have a RockSim file example for the 2024 American Rocketry Challenge? And Art, the answer is yes, but I can't give it to you. It's one of those things, it's like, we can't help you design your rockets for that challenge. You know, that's a student challenge. We can go through that here. Design the rocketry, the challenge. I'd have to bring up, I think I remember the rules. I just don't remember the altitudes that you have to try to achieve. We'll do that one as well. So where was I? So that's RockSim. If on our website, if you go to the How To and Guides menu, you click on that, come down here to Software. This will give you more information on RockSim, you know, downloading the free trial, where to purchase it, FAQs, you know, system requirements, what computer do you need. It works under both Windows and Mac, including Windows 11. There's a version history, you know, things that have been changing. Again, the link to the RockSim Live training, other tutorials, more stuff, lots of stuff here on the menus to think about and look at. Alright, so let's get into the questions. So if you have a question, that's what we're here for, is answering your RockSim questions. Or RockSim Pro, or the Launch Visualizer. We can do them all today. We had our first two questions come in. The first one was from Bob Monday, and he says he's planning on using redundant RRC3s. So what's an RRC3? So if you go to the Apogee website and you type in RRC3, and I gotta get out of the stupid menu. RRC3, type that in, and you'll see it's a dual deployment altimeter. And this is what it looks like. It's a nice pretty thing. We do sell them $103. We do have them in stock. It is dual deployment. So he's doing a redundant design. So the big question, let's open up a design here. Let's open up maybe like the Katana. So the Katana is one of our Apogee kits. So I'm in RockSim right now. This is what it looks like in 2D and what it looks like in 3D. And if I come over here and I can recenter the camera to the default view. So that's what it looks like, and I'm just zooming with my scroll wheel on my mouse, and you can also rotate it, look at it from any angle that you want. This is a big high power rocket, and if you go back to 2D I can give you some dimensions. It's 74.8 inches long, 4 inches in diameter. It does have an E-bay right here in the middle. So his question is, how do you simulate redundant dual deployment? So if there's, I'm looking at the image here and I see a P, that means a parachute. I see a parachute here and I see another one back here. So this is set up for dual deployment. So let's run a quick simulation. So I'm starting the simulation by clicking here, and this is prepare for launch, that button. And it brings up this screen, and it shows the motor mount, so it's looking for a rocket motor, so I'm going to choose an engine. And I'll choose, I probably don't have that J615 in yet. Ooh, look at there, a J615. How cool. Didn't know that was in here. Click OK. So we just added that aerospike nozzle rocket motor in here. Okay, so under flight events, this is where you set up dual deployment. So we have, this is our drogue parachute, and then we have the main parachute up here. The drogue parachute, we want to deploy it Apogee, and the main parachute we'll deploy at an altitude of, I don't know, we'll make it 400 feet and hit tab. Simulation controls, I'll just leave that alone. Starting state, this is the launch pad, so this is the launch guide length, so that's how big is your launch pad. Rail, so it's 98 inches long or 8 feet, and the launch angle, we'll give it a few degrees. And then the launch conditions, we're at an altitude of 700 feet above sea level, and we got a wind of 8 miles an hour, and let's see what this looks like just to verify that it looks normal. So there's the rocket sitting on the launch pad there, and we click the launch button, and you can see the smoke coming out, and now it's coasting. And our altitude is 3,000, 3,600, 3,700. Oh, we've reached 4,000. We're still climbing. Okay, so there's our Apogee. And now it's coming down and it's falling pretty fast. When it gets down to 400 feet over here, we'll see the big parachute come out. And in the 2D flight profile, what you'll see is that this line of dots right here will change direction. It'll kind of go more this way as the rocket starts drifting with the wind because it has a bigger parachute. We're still at 2,000 feet, so we got a little bit of way to come down yet. We're at 50 seconds into the flight. 1,700 feet, still falling, still falling. So the purpose of dual deployment is obviously so you don't have to walk as far because it falls fast during this phase. 900 feet, still falling, getting close. And at 400 feet exactly, this will pop out, and right there. So now you can see that the rocket is kind of more going a little bit more horizontal because it's descending slower and it's just drifting with the wind. But if it would have been on this path when it was way up here, it probably would have landed way out here. So we're already 877 feet downrange. So, you know, we probably saved ourselves a couple of thousand feet of walking by having dual deployment there. So everything looked okay there. So the question is, what do we have to do if we're doing redundant electronics? Well, as you saw up here when we prepared for launch, the electronics, basically they control when the parachutes come out. So that would be under flight events. And you'll see that it doesn't really matter how many altimeters you have in there. It's still going to fire only one parachute at a time. So you might have both igniters going to one parachute, you know, on your drogue, and another pair of wires going to your main parachute, one from each altimeter. But it's only going to do the same thing. It's only going to set off one at a time. You know, having redundant altimeters doesn't really change the setup of the, you know, for running the simulation. The only thing that it does is it changes the mass of the rocket, because now you have two altimeters in your rocket. And if I go back here to the web page, I think I should be able to find the mass of this. Yeah, 17.01 grams. So basically, if we added another 17 grams, and if you have an extra battery, so you probably have to add maybe another 20 grams for a battery. So we're at 38 grams, maybe a few more grams for the wires to go to the ejection charges. You know, you might add 40 grams of extra mass, and the easiest way to do that, you should go to the rocket design components right here. Find in the rocket where you want to add it, and you'll probably add it into your eBay, which is right here. And I'll click on the switch band, and this brings, these are all the components in my eBay. And so here's the coupler tube, and so if I go up one level, I can add a mass object here. So basically I just want to add maybe 45 grams for a second altimeter. And so when you click on the mass object, it brings up this right here, which is the database of parts, and I'm just going to cancel out of that. And I'll make this screen a little bigger. And you see this M right here with the circle, so that's our mass object. And we'll call it, I don't know, we'll call it 45 grams. And the location, I don't know, maybe we'll move it just a smidge that way. And let's call this redundant altimeter. And it's 45 grams. Click OK. And so now we have that second altimeter, and if we run the simulation again, I'm just going to launch. Okay, so it launched it again. Oh, I say, why did this not change? It's exactly the same as it was before. And then I look down here, and it says user specified selected stage. So what this means is there's a mass override turned on. So a mass override, which we've discussed before, is basically saying I've got a rocket. I can either let RockSim kind of estimate the mass, or I can actually put it on a scale and weigh it. And if I do that, I'm going to override what RockSim thinks it weighs. That's why we call it a mass override. I'm just going to say, ignore what RockSim does. I'm using this specific mass. And to turn that on, it's up here on this tab called Mass Override. And it's checked right now. It says use the values shown below for all the simulations. So by having that mass in there, the mass override, it is overriding what RockSim would do, and no matter how much extra mass I put into the design, this global mass override here is going to say ignore everything except for this final number. So even though I put more mass in here, this mass override, it overrides it. So you can't, if you want to make changes, then you'd have to make changes here. So I think I added 45 grams. So if I wanted to change it, I could say, 45, so that'd be 55, 20, 55. And now if I run a simulation and launch, you'll see my number is a little bit lower than the last time. 90, what is that, like 20, 25, 30 feet, somewhere in there. I lost 25 to 30 feet because I added an extra 45 grams to this rocket. So adding a second altimeter, not going to change the altitude that much. It's in the margin of error, actually, So if you had, the way I did it would be fine. Just use a mass override or add a mass object. And that's how you would add that second altimeter in there. Okay. Art Apple White says, do you have a RockSim file example for the 2024 American Rocketry Challenge? I know we've done one here at Apogee because we're trying to plan ahead for next fall. We're trying to figure out what motors people might want to use. So we run the simulations, and we have to stock. There's so many schools, and we have to stock a lot of different motors. So we're just trying to figure out if we can reduce the number of motors that we have to order by running the simulations now, and because we can't stock everything, especially in the quantities that the schools need. But if you wanted to design a TARC rocket, I could kind of go through. So let's do, basically when I design a rocket, I like to cheat as much as possible by grabbing other designs and then just modifying them. The rules for the ARC competition, American Rocketry Challenge, they changed the name on us again, state that it has to be where the egg is at the portion that contains the egg has to be 2.25. So basically it's a BT-70. So they try to design, when they make the rules, they try to use common tubes. And so the BT-70 is the common tube where the egg is going to go. So when I started design, I'm looking for something that might be BT-70 size. And I'm in the Apogee folder, but if I go to the Dynastar folder, open that, and we could, let's start with the Stonebreaker. I know that one is a BT-70, and it's just, I know because I designed it. So if you don't know, what you could do is you go to the Apogee website, and I'll show you how, if you didn't know what diameter a rocket was, and you wanted to use the same kind of shortcut that I do. So this is a message for Brendan. How to make a shortcut designing for TARC or ARC. by starting with an existing design. So how do you find a design that you might modify? So go to the shop menu, and then in the shop menu, go to this one down here at the bottom that says Rocket List, the sortable list, and click on that. And this is going to give you a chart showing all the Apogee rockets that we sell. And this is a sortable list, which means that I can, these columns right here, if you click on them, it will resort. So if I click on a rocket name, it's going to sort alphabetically. So I click on that rocket name. See, now if I click on it, it's sorted by reverse alphabetical. And if I do it again, now it's alphabetical. But we know the diameter is going to be a BT70. So I'm going to come over here to the, this is the diameter column, and there's so much information here, so let's turn off some of these columns. Let's turn off stock. Come on, why is this not letting me click on this? Oh, it's on auto. So let's turn off stock, let's turn off price. Highest flight and lowest. See, if I'm, by doing that, I'm making my column a lot easier to read. We can turn off the launchpad one as well. Alright, so now we are on, now we can see the diameter better. So now if we sort by diameter, and you can see that this one varies, but again, it's sorted by lowest to highest. So now we just want to scroll down on this list until we get to the approximate diameter of a BT70, which is about 2.2 inches. So I'm just scrolling down until I see 2.2 inches, and then there's a lot of kits that are smaller than this. So I'm still scrolling. I'm sorry giving you vertigo here by scrolling so fast. I'm trying to pause every now and then so you can catch up. Okay, so here is where we're getting into things that are 2.2 inches in diameter. So this is the area, and so here's the Stonebreaker, is as in one of the rockets that we can use. We can use the Zephyr Jr., the Stonebreaker. I think I'll use the Zephyr Jr. in fact. So, so I'm going to click on that link, and it's going to take me to the Zephyr Jr. web page. And then scroll down here to this bar. That's this is kind of like a menu, and if I click on RockSim file, it'll jump down to the a lower part in the page, where you can download the RockSim file for the Zephyr Jr. So if you click on that, you can see it put it in my downloads folder, and it gave it a number 1, which means that it was already there. So where's my downloads folder? So if I'm in RockSim, and so I just downloaded it, so now you have to find it. So if I click File Open and go to my Downloads folder, and why am I not seeing it? It should be there. Downloads, desktop, not there. Downloads, what happened? Let's try it again. See, now it's giving me number 2. Let's see if I click open file here, what happens. Well, there it is. It's we can do RockSim Pro. Choose an app on your PC. So I'm looking for my RockSim app. My program file. I think I want to be in the programs x86. Yeah, there's always 2 program folders on Windows. I don't know why it does that. Here's RockSim 10, program folder, RockSim, open. Let's see if it opens. There we go. Look at that. It opened it. Just like last week. Now we got 2 instances of RockSim open. So here's the Zephyr, and it's a 2.2 inches diameter. So now we're going to start modifying this. And so if I recall the rules, it says it's got to be 2.2 inches for where the egg is, and then it has to have a second diameter that has to be bigger, and I think it's BT80 size. So you can either put the egg in the bottom or the top of the rocket, it doesn't matter, but I would probably put it in the top, because we know that by putting the egg forward, it moves the center of gravity forward, and that makes the rocket more stable. So we need a transition and then a lower stage. So let's go to the components. And so we have this aft body tube right here, so let's add a transition to that. So you select the tube and come over here to transition, hit that. And so here's we have a BT70 to a BT80. I'm going to click OK on that, and that's the transition that we sell here at Apogee. That should work. You can see it looks kind of weird out here with the fins forward. There's nothing that says you can't have fins up here. I think I like everything here, so I'll click OK. And now we'll add another tube to this. So I'm going to hit body tube, and then I'm going to select a BT80, which is 66 millimeters. And you can see that it's sized correctly, but it's probably too long. I think there's a maximum length on the Tark rocket. Here's the length, 49 inches, but I can just take this length slider bar here and I can just make it shorter. And I do that, and I say, yeah, that looks good. And we'll call this the body tube BT80 so I can tell them apart. Click OK. It looks kind of like a 2-stage rocket, but it's not. It's just that the fins are at the front. So I'm going to take these fins right here and I'm going to move them down here. So I'm going to do a copy and paste because I'm going to delete them off of this one here. So right click on the fin set, do a cut or copy. I'll do a cut because that automatically copies it to the clipboard. And then select the body tube right here and then do a right click and choose paste. And it pasted the fins down there, which I like that. Our motor mount is also in the wrong spot. I think this tube right here, it says body tube. And yeah, we can do the same thing. Do copy and cut and paste. Cut. Say yes. Come down here to this tube and do a paste. They pasted that motor mount here. Now these centering rings also have to be moved. Cut. Yes. Paste. Okay, pasted one of them here. Here's the other one. Oops, right here. Cut. See, this doesn't take too long. This is fairly redundant. Paste. I pasted it down there. That looks good. This launch lug is probably going to have to move as well. It's what we call a rail button, so let's move that. So let's cut that. Say yes, and paste it here, just as before. Look at that. So So we have the parachute up here. We'll probably have to put the parachute in the bottom as well. Cut the parachute, say yes. Down here at the bottom, let's paste it. So I pasted it here. I do want to open that parachute, see what size it is. It says it's 32-inch diameter. So let's change the name of this, 32-inch parachute, so I know the name of it. And it's probably going to be overkill, but we'll start with that and we'll adjust it later. I can see that it's interfering down here with the motor mount, so I'll just move it, the location, a little bit forward. Right there. Yeah, maybe I might want to move it even further. Yeah, let's leave that. Click OK. We do need an egg in here into this body tube. So that you would probably use as a mass object because there's no button here that says egg. So use it as a mass object. And I don't know if there's an egg in here, but I think an egg is about 60 grams. So let's cancel out of there. We'll just add a mass of, I don't know, let's call it 75 grams, and we'll call it the egg plus protection. Okay, and right now the egg is right there. Let's slide it like right to the middle of the tube. And we might protection and altimeter. And we might want to add some more mass for the altimeter itself. You see how easy that is. This is going to give us a rough idea. Click OK. Now this nose cone, we'll probably want to use a nose cone that's, we sell a nose cone that is really popular for these rocket competitions. If you go to the Apogee website, let's go back to the top of the page. And let's call it a foam nose cone. Okay, here's a 56 millimeter Tark foam nose cone. That's the one that we want. And you can see the shape is a lot different than the one that's in our design. And you can get the dimensions right here. And we put these dimensions in here so that people can get an idea how big they are specifically for these Tark competitions. So I'll close that. It's 2.5 inches and it's kind of a hemispherical shape. So on my nose cone, I'm going to find the nose cone and I'm going to adjust it. And let's make it elliptical, length 2.5 inches. And you can see that's much closer to what we have there. We might want to change the material to flexible soft urethane foam, and we'll call it a solid nose cone, and it gives us a mass of 8 grams, and it's got a core in it. I think the core was like 2 inches, I don't know what it was. And it was, I think, 736. Okay. And click OK. So there is our new ARC rocket, and let's do a save as. File, save as. I'll put it on my desktop, and we'll, instead of Zephyr Junior, we'll call it, Tark 2024 rocket. 2024. Hit save. So that could work. Let's see what it looked like in 3D. It's kind of generic looking. That's probably what a lot of the rockets are going to look like. And so the next thing you want to do is kind of look at the mass. So you know, right now I don't have anything to go on as far as what kind of mast that I'm going to need. But then it's, at this point, we could start picking rocket motors. And so what I would do, so right now I think this motor mount is a 24 millimeter diameter. And you can confirm that by going to the tube here, and edit the tube. Let's change the name to motor mount. And yeah, right over here it says 24 millimeters, so that's okay. So to pick a motor, to kind of give a ballpark of what might work, what you would do is you come up here to simulation. Before we clicked on choose motor, that this time I'm going to say recommend motors. I'm going to click on that button, and I'm going to change the launch guide length to at least 6 feet, and then use recommended conditions, and these are the recommended conditions right here, so we're just going to use those and let RockSim plug through all these, and there was 51 of them, and it didn't like about 6 of them. So now it says we're down to 45 of them, and it's rerunning all the simulations to try to figure out what delays we might need. And it's moving pretty quick. We should get there in just a few seconds. Okay, what happened? Okay, I brought it to the back. But it did run all the recommended motors. And you can see here, some of them are not recommended. Here's like the Estes E9, not recommended. So that one we could say we're not going to use. And now, let's see, I can come up here and right click on this and drop down to say, oh, show only the recommended motors, so that I don't see the non-recommended motors. And so now the entire list will be just recommended motors. And now we want to kind of like, what is the maximum altitude, because that's what this competition is really all about. And again, these are sortable, so if I click on it, it will sort it from the lowest to the highest. So a C11, don't want to use that because I'm sure the altitude is a lot higher than 175 feet. And say for example it was 800 feet. So I would just scroll down until I see the first one, you know, that's in the 800 foot range. And so, you know, we're close here with an E22. An E75 would work, but that's a VMAX. So at this point, now we're kind of starting to make design decisions. But, you know, this E31 is in the ballpark as well. That might be a good motor. Even the Estes E12 might work with a single egg. That could work this year. A Quest E26. And then we start getting into motors that are going to go a lot higher. So if they're going to go a lot higher, how do you make the rocket fly lower? You know, you just add more weight or increase the drag, and that will drop your altitude. And so now you have a number of design decisions. So that was how quick it was to create a TARC design. It doesn't take long, and you know, you could take your rocket from last year, start modifying that, but this would probably be a rocket that could be used. But the process was, we found a rocket that had similar diameter to what we were going to use. Then we downloaded the RockSim file for that, and then just started modifying it by moving parts around. You know, we recycled the fins, we recycled the motor mount, and then just moved everything else around. You know, we moved the parachute from here to here, moved the motor mount. Really the only new parts were the transition and the tube itself. And it just, well, we did swap out the nose cone, but we did that because the foam nose cone gives you a little bit more protection for your egg. You know, if the rocket would come over the top, it's hanging by its parachute, and it usually points down, so the nose cone hits first, and if it's nice and soft, it'll kind of flex and give a little bit extra protection. That's kind of why we made that nose cone. Give you a little bit more protection on your Tark rocket. We might have to change the names of these things, but most people will recognize it for Tark. Okay, so that answers Art Applewhite's question. Yeah, I can't design the rocket for you, and I can't share my file because that would be like designing a rocket for you. So I just wanted to go through the process to show you that it's not hard, and you can do it. Says HPR says Robert had a question at the top of the chat, and that was, yes, I did answer that one already. That was about redundant altimeters. Fatbank says, I have RockSim Pro, but no credits for the launch visualizer. Do I need to buy more credits? If you have RockSim Pro, you do not need to get the launch visualizer. The launch visualizer is built into RockSim Pro, so you already have a subscription for it. Now there are a couple of things that the launch visualizer can do, but then at the same time there's things that RockSim Pro can do that the launch visualizer can't. But normally I would just use RockSim Pro. So let me save this design here. And I have RockSim Pro open somewhere on my desktop. That was our other instance of RockSim. Here's RockSim Pro. I can see it says RockSim Pro. So, you know, if I can load that design, and it was on my desktop. I swear it was on my desktop. Where is that design saved? It says desktop, Tark 2024 rocket. It's kind of like I'm not looking at my desktop. Where are all my rockets? Oh, there it is. I was looking right at it. Okay, so I'm in RockSim Pro, and you can see it looks a lot like RockSim. But it's different under simulations. So if I go to simulations, and I'm going to choose that E12 motor because that was getting us pretty close. And I'll choose an 8-second delay, engine overhang of 0.5. Under flight events, parachute will open at max ejection delay, starting state. It's still a 8-foot long launch rail. It's launched straight up, and because it's straight up, my azimuth angle, this is like a compass. And no matter which direction the compass is pointed, since the rocket is pointed straight up, it doesn't really matter. But what does matter is where you launch from. And I'm not sure where this launch site is. I think this is at 13,000 feet. Holy cow. Last week we were playing about with launching from a balloon. I'll go into the Longmont Rocket Club launch site, and then instead of just clicking launch, we'll go to the flight profile, and when you hit this, it will bring up the launch visualizer that's built into RockSim Pro. And so that's why you don't need to have credits on the launch visualizer. So this is a park in Longmont, Colorado, and I just lost myself and I just spun myself around. Whoa, gave myself vertigo. Let's change this to a trajectory view. and find the rocket. And it should be right in the middle of the screen, so it's got to be somewhere right here. When we click launch, we'll see the smoke coming out. There it is. And the rocket's going straight up, and our altitude is over here, 800, it looks like it had touched 850 feet. And now the rocket is coming down. It's hard to see because it's so small compared to our thing here, but if I pause it, and if I click on the settings up here, and I say show me the trajectory path, and I change the color, I'll make it green so it's a little easier to see. We don't need to see the points here, and click OK. And so now we got this pink line, but if we spin our rocket around, the compass around, you can see okay, so here's the park. The launch pad was right here. This green line is the trajectory. So the rocket went up, hit the apogee point right here, went over the top, and at this point something happened, and I would guess that that's where the parachute came out, and now it's descending downward on its parachute, and this little dot right there, if I scroll in, it will be the rocket hanging by its parachute. So you can see it's kind of small in the grand scheme of things. And if I scroll forward in time, I can see where the rocket lands. It did not land in the parking lot of the park. It looks like it landed in the parking lot of this building right here, which I have no idea what it is. In fact, it looks like it landed in a tree and some bushes right at the corner of this intersection of Vista View Drive and Sandstone Drive. So that kind of gives me the lay of the land of where this rocket might likely land, and you can see a lot. So you don't need to subscribe to the launch visualizer to use this. It's already in RockSim Pro. But if you don't have RockSim Pro, you can get this by subscribing to the launch visualizer. Carlos K. says, I really enjoyed the fin fillets part 1 strength discussion. Question number 1, would drilling tiny holes in the body tube under the fins and squishing in a lot of glue, making glue rivets, help the glue grab better? And the answer, Terry, is actually yes. That's a lot of people would just take a pin or a needle and then just, poke holes into the tube underneath the fin, and on that line there you're going to glue the fin and then put your glue on there. And yes, that does add some strength. As you saw in the video, the weak point of any fin onto a tube is actually the paper tube itself. That's where it breaks. So by putting these little tiny rivets in there should help a little bit. I don't know exactly how much strength it's going to add. The only way to find out is to break a fin off and to see if it took more force to break the fin off than not. And Terry Wheelock says, yes, Carlos, it gives a 10% greater grab. Toothpicks give 20%, and through hole give 100% greater grab. Yes, I don't know about the exact percentages, I don't know, but definitely it adds strength. So I do agree with Terry, and through the wall fins is the strongest, because now you're completely ignoring the weak link, which is actually the tube itself. Art Applewhite says 820 feet and 250 meters is the challenge for the TARC launch this coming year. So I was not too far off, 20 feet off. Here with this rocket, I could probably get it. It's a lot easier to make the rocket fly lower than it is to go higher, because you just add in a little bit more weight. Terry asks, is TARC ever going to do a VTVL challenge? I guess that means vertical takeoff, vertical landing challenge? Maybe. I don't make the rules. So I'm talking for them, and I'm saying yes, maybe. Vertical landing challenges. It can be done. We have a kit. I think you're thinking like a Falcon 9 where you're landing under rocket propulsion. But if you just want a vertical landing, we have a kit. What's the name of that kit? The Mega Lander. So if I type in the search bar Mega Lander, and it's called the Starlift Mega Lander. And let me see if I got a picture of it. Rocket landed on the ground. It's got these legs that spring open. And when it is that all the photos I got? I should have more photos. There's a rocket takeoff. See the lander. Once the parachute comes out, the legs spring open and it can land vertically. And it lands vertically most of the time. I think I had a video here. Here's a picture of it. What it looks like when it's landed. But that's only part of the rocket. There's actually the nose cone part which separates. But it might be possible to make the nose cone land right next to it. Here's a video if you're really interested in it. Terry says, can we design and simulate that in RockSim, that vertical landing? Well, maybe. When we did this rocket right here, and we were in RockSim Pro, and we were in the launch visualizer, and if you look at the rocket when it lands, it is vertical. See, it's vertical. RockSim Pro doesn't know that the rocket falls over. It just keeps the rocket in a vertical orientation. So, yeah, you could design that. Now, can you design legs that spring open? That is a no. I was just trying to think, is there a workaround for that? That's one of my ideas that I'd like to add in the future of RockSim is deployable fins. And I've been talking with my programmers about it, but they're working on other issues first. And I just had to get my head thinking, have we already started working on that? I know we've been talking about it. So I think that's all the questions that have come in. And it's already 3 o'clock. Can you believe that? Where has the time flown by to today? Yeah, so that's all the questions that people have asked. If you have a question, you can come to the Apogee website and use our contact form and submit a question there, and we can take it up in a future episode. We are here on Friday afternoons at 2 p.m. Mountain Time Zone, which is 4 p.m. on the East Coast. So that's when we would answer those questions. So anytime between now and next Friday, the questions can come in, and we'll think about them and we'll answer them. But you can always ask the questions live at the same time. And I know a lot of people do. They'll submit a question, but then they don't want me to forget about answering it, so they'll submit it again, which is great. That always reminds me. So We will be back next week. Say today's the 2nd. 2 plus 7 is 9, so that should be June 9. I'm not going anywhere. The following week, I will be out of town, so Michelle will be here in 2 weeks, but next week I'll be here. And yeah, so until then, go out and launch something. I think we have a launch tomorrow as well. And we just had one last weekend at NSL. That went great. There was a lot of people there that said hello. A lot of people said they watch our videos. And some people even watch the RockSim Live ones as well. So until next week, go out and launch something.